This video focuses on lines. As we already mentioned, lines are going to be important in calculus because one of the central notions, especially at the beginning of this class, is tangent lines. Tangent lines tell us something about how a curve is changing at a certain point. We're going to need to know the following things about lines: what slope means, how to write equations of lines, and how to graph lines. Another resource at your disposal is this document, which gives learning outcomes for each section of the textbook. It also gives some recommended practice problems and indicates the difficulty of those practice problems. As we mentioned, lines are covered in section 1.2, and you can see that the first two learning goals are about lines, and there are many practice problems that go along with them. Here's the graph of the line y equals 3x minus 1. We can see that the slope of this graph is 3 because if you look at any 2 points on the graph, such as 0, minus 1, and 2, 5, when we calculate the change in the x-coordinates and the change in the y-coordinates, their ratio is 3. And we can see that graphically. Here's the change in x, and here's the change in y. For every step I take to the right, every time I change x by 1, I change y by 3. I take 3 steps up. So the slope of a line is calculated as change in y divided by change in x for any 2 points on the line. You may have also seen this written as rise over run, because change in y represents the vertical change, and change in x represents the horizontal change. What about writing equations for lines? You're probably familiar with the equation y equals mx plus b. This is the slope-intercept form of a line, because m represents the slope, and b represents the y-intercept. And that means that the point 0b is on the line. In other words, the line intersects the y-axis at the point 0b. This is convenient when you know the slope of the line and you know the y-intercept. But it's more common to have the slope and just an arbitrary point AB. If we're just given the slope and any point AB, the corresponding line has the equation y minus b equals m times x minus a. This is known as the point-slope form of the line. And depending which point you use, you'll get a different equation, but they will all be equivalent. For example, if we want to find the line with slope 2, which contains the point minus 1, 3, then the equation would be y minus 3 equals 2 times x minus negative 1, also known as x plus 1. Notice that if you plug in this point, x equals minus 1 and y equals 3, you get the equation 0 equals 2 times 0. That's a true equation, so the point negative 1, 3 is indeed on this line. What is the slope-intercept form of this same line? Pause the video for a moment to think about your answer. If we distribute the 2 in the product on the right, and then add 3 to both sides, we get the equation y equals 2x plus 5. That's the slope-intercept form of this same line. And if you were asked to find an equation for this line, either of these two equations would be a perfectly good answer. What about graphing? If you have the equation for a line, it's not too bad to graph it. If you plug in any two x values, you can use them to find 2 points. Then you plot those points and draw a straight line through them. However, it's a good idea to know heuristically what the line should look like based on the equation, to know how the slope affects the picture of the line. Here we have the graph of the line y equals 3x minus 1 again. This has a positive slope of 3, And it's increasing. As you move to the right, the line goes up. Whenever you have a positive slope, you'll see that the line is increasing. On the other hand, if you have a negative slope, like for this line, y equals negative x plus 2, then the line will be decreasing. When you compare two lines that both have positive slopes, like the red line and this green line, the red line is much steeper because its slope is 3. That's much bigger than the slope of the green line, which is 1/5. Also, notice that the equation for the green line that I'm using, y plus 1 equals 1/5 times the quantity x minus 3, is in point slope form, and the point being used is 3, negative 1. Similarly, if we compare two lines with negative slopes, this blue line has slope negative 1, and it's not as steep as the purple line, which has slope negative 2. The equation I'm using for the purple line here, y minus 2 equals negative 2 times quantity x minus 1. That's the point slope form going through the point 1, 2. Pause the video for a moment and try to remember what the equation for a vertical line looks like and what the equation for a horizontal line looks like. Also, what are the slopes of vertical lines and horizontal lines? A horizontal line has the equation y equals a constant, like this one, y equals negative 2. Horizontal lines have slope 0. Whatever 2 points you choose, the change in y, delta y, is going to be 0. Vertical lines have equations x equals a constant. Here's a vertical line, x equals 3. When we try to calculate the slope for a vertical line, we get delta x is always 0. That means we calculate slope, we're trying to divide by 0, which we can't do. So vertical lines do not have a slope. You can't write them in point slope form, you can't write them in slope intercept form. Both vertical and horizontal lines are going to be important in Chapter 2. In Section 2.4, we learn how vertical asymptotes relate to limits and continuity. And in Section 2.7, we use limits to calculate horizontal asymptotes of graphs. Please go on to the next video where we'll talk about parabolas and factoring.